Welcome to Pomodoro Joe for Friday, February 3rd, 2023. Today it looks like we're going to do LeetCode problem number 6, Zigzag conversion. This is a medium problem. And the problem statement says, the string PayPal is hiring is written in a zigzag pattern on a given number of rows like this. And then they show you this PAY going down the first column and then up to the right, PAL or PA, and then dropping down the column, LI. So it looks like it goes down, up to the right, drops down the column, up to the right, drops down the column, up to the right, and so on and so forth. And then it's read line by line. And so we're going from the first row, second row, third row, and concatenating them all together. So PAHN, APLSIIG, YIR. So our goal is to write the code that will take a string and make this conversion given a number of rows. All right, so they give us a string, they give us a number of rows. We have to figure out the zigzag pattern and just concatenate all the rows from row 0 down to the end and return the concatenated string. Okay, got some constraints, lengths less than 1,000, and it looks like we could have one row up to 1,000 rows. Okay, if num rows is 1, we can return our string because we don't have to do any zigzags. So I'll be honest, my initial thought for this one was, well, there's some mapping from the input index to the output index. So your character at index 0 on the input maps to character 0 on the output. That's pretty straightforward. But then you map from 1 to, it looks like we've got to go down to about 5. And then you go from 2 to, let's see, where's the Y? It's way down at the end here. So there is some mapping between the input index and the output index, but that's a lot of math. That's too hard. Let's not do that. Let's just do our zigzag pattern. I think I can handle that. Okay, so we define some coordinate system where the top left corner is 0, 0, and y is increasing as you go down, and x is increasing as you move to the right. So we'll start off at 0, 0. And then we need to define which direction we're going. We're either going straight down or we're going up and to the right. And now we can just say for every character in our input string, well, shoot, this is where it gets complicated again. We need some grid to store our characters. Well, shoot, I don't have one of those. So for now, let's just pretend. We'll say I have some grid. And at our x and our y, we will store our character. All right, fair enough. We can come back to that grid later. Now, how do we do this? Well, if we're going in the down direction, then we add 1 to our y. Otherwise, we must be going in the up right direction. So then, let's see, we subtract 1 from our y, and we add 1 to our x. So what happens when we reach the boundaries? That's either we've exceeded the bottom or we've gotten past 0 on the top. Let's start with the easy one. So if y is less than 0, well, that means that we were going up and we need to turn around and go back down. So now down is equal to true. We're going to head back down. And our y, well, we just placed 1 at 0, so we need to go to 1. So as you can see, we were heading up to the right. We got to 0, we started going past 0, now we have to jump down to row 1. Okay, so that takes care of the upper limit. Now if y is equal to our num rows, that means we've exceeded our lower row, our, let's see, our bottom row here. Okay, well in that case, what do? Again, we need to turn around, so down is equal to false. We're starting to go back up. And then y, this is a little bit trickier. So we had just placed 1 at our last row on the bottom, and now we've exceeded that. So we have to go back at least 1 to get to the bottom row, and we have to go back a second one to get to our next placement. So that's minus equals 2. So now we have our zigzag pattern worked out. We just need to figure out what to do about this grid here. So again, like my gut is like, oh, you'll just create a grid and you already know how many rows you need. You just have to figure out how many columns per row. That's again too much math. I don't want to do that. So instead, I'm just going to store X, Y, and Z as an element. So here's the plan. We know our X, Y coordinate for our character. So we'll just hold on to that. And then we'll just sort all of these elements by their Y, meaning their row. And then we'll concatenate those all together. Seems pretty straightforward, right? So we have some element array, if I could type, and we'll just append this element to the element array. And now we've built up all our elements. We need to sort them by row. So the easy way to do that is just to say element array dot sort. And now you can pass in some sorting function. It's called the key. And we're going to pass in a lambda function. So a lambda function is just sort of a nameless function. You give it an argument, and then in our case, we need to return a tuple. So we're going to return y first, which is our element. So you can see we have x, y, character. So we need to sort by y, which is our row, at 1. Then we need to sort by our x, which is at 0. And we can completely ignore the character. It doesn't really matter in terms of our sorting. Now that we've sorted these all, we need to put them back together into a string. So we have some result string. And now for our element in our element array, we just say a result. We'll just append that element's character, which will be the element at element 2. And then we can return our result. All right, let's take a look. How do we do? Okay, and we pass. Let's submit that and see how well we do. Not too bad. We pass. We beat 47% for runtime, 17% for memory. Let's see if we can make some improvements. Well, one simple thing we can do, I'm already checking to see if we only have one row. What happens if we have more rows than we have characters in our string? That means we just have one column, and when we push that all together, we still just return our string. So we can say if the number of rows or if the length of our string is less than the num rows. Cool. And now let's submit that, see if that one little change gets us any improvement. A tiny bit. We go from 47 to 48, so not a lot. What else can we do here? Well, let's see. One thing you might have noticed is we're incrementing these y's and these x's, and then we're appending these into our element array here. Every time we're doing this, our x is actually only increasing. We're never decreasing our x. So we really don't even need to keep track of our x value. What if we just didn't bother with the x value? Well, let's try that. So we'll get rid of our x value. We can do that. We don't need this anymore. We don't need. Okay, I think that covers the x value. And then when we do our sort, we actually only want to sort by our 0th element because we got rid of our x value. Okay, let's see if that works. Oh, yes, I need to change this as well. Okay, that still works. Let's see if that gives us anything. Oh, that's a pretty decent bump. Now we're up to 61%. All right, where else can we make improvements? Well, so another thing here, we're keeping track of this down and we're flip-flopping this value here. What if we just got rid of down and had some y step? So let's do that. So we start y at 0, but now we have our y step. And that's going to be how much we're going to change our y each time. And we're going to add 1 to start with. So we don't need to keep track of if we're going up or down. We just say y plus equals our y step. And now, instead of saying, oh, we're going down, well, if we're going down, we'll set our y step equal to 1. We can get rid of this. And if we're going up, then we set our y step equal, let's see, equal to -1. And we can get rid of this. All right, so that's cleaning things up pretty nicely. It's a lot shorter. Let's try this. All right, let's submit that. 89%. That is not bad at all. Huge improvement just by getting rid of the Boolean, the up and down Boolean, and changing it to the y step. That might be as good as I'm going to get this one. There's one other thing we could be doing. So you might notice that now that we got rid of our x and we're just using our y's, when we append our element here and doing our sort, we could actually keep, instead of keeping one element array, we could keep an array of strings. How do I put this? Instead of keeping an element array and then sorting it, we could just keep, here, I'll show you. We could keep a list of strings for that row. Let's just call it rows. Basically, we need an empty string times num rows. Okay, so instead of keeping our element array, we'll just keep every row, and it'll be starting as an empty string. And then instead of appending the whole element here, we can get rid of this. And we just have our rows at y. And we'll just concatenate the character onto the end. So it starts as an empty string, we put the character on the end, and see our y will be keeping track of what row we're on, so the index into this rows. And then we don't need this sort anymore. And we don't have elements, we can get rid of this element. We still have a result, but now our result is basically for every row in our rows, we can say our result plus equals that row. Let's just see if that still works. That still works. And we can run that. 74, that actually drops us down. We lose, I think we do better in memory, 94% for memory, but we lose on the runtime. Yeah. And the last thing we can do here, instead of iterating through all of this, we can use the join function. So string join, and we'll just join our rows, and we can get rid of all of this. It might be a little bit faster because it should be doing it like in C rather than in interpreted Python. Okay, I think that is probably as minimal as I can get this one. And we will give that a shot. 81% with 94% beats 94% from memory. Okay, so turns out our join didn't actually save us anything. Well, it saved us a little bit, 74% up to 81%, but our best so far was still the 89.23% runtime, 29% memory. All right, there you have it. Hope you enjoyed this. Hope you had fun. Hope you learned something. I will leave a link to all my code in the description. You can check it out on GitHub. You can also check out this problem on LeetCode. Again, this is problem number 6, zigzag conversion. Give it a shot. It's a fun one to iterate through. Hope you enjoyed it. Hope you had fun. Hope you learned something. And I hope you can go out and write better code than me.